in the program. I have extra copies. You can pick it up on your way out. Next week, we will have a group of people who did a startup, founded a startup in San Jose. They are very interested in student participation in terms of trying to destroy their product. And they said, do you have any students who are capable of destroying the product, our product? So I invited them to explain. And that will be next week. Today, I'm very happy to introduce you to Tuoshi, who worked for Alcatel and is working for Yahoo. And is here to tell us the secrets of search engines.
I'm a little bit sweaty because I rode my bike here. It's not totally because I'm nervous. So the topic is search engine basics and some of the challenges we face. Here are some of the topics that I'm going to cover in full text. I know most of you probably know a lot about these already, but I'll just quickly give an introduction. Full text search and web search, how to scale it, and so what kind of problem we're facing when we do the search engine, and globalization. How do you deploy search engine all over the world? What kind of issues you have? And some of the challenges and FAQs that I got asked a lot by people. So here, full text search is something that basically you want to search a word in the document, anywhere in the document. As compared with the partial search, is you search either the title or the header or the abstract. So that's the difference. Basically, full text search is basically more complete. You index the entire document rather than index part of the document, just the title or a small portion of that. So the way to do the indexing and search is when you get a whole set of documents. Well, if you have any questions, just interrupt me. Otherwise, I'll just fly through the slide. So basically, you have a set of documents. These are the words within the document. You build a forward index. Basically, for each document, you list what words are in this document. So that's your forward index. It's very natural, very easy to do. Parse out the document, separate by space or comma or whatever, and take out the words. Build the list. You can build an index in parallel because each document is independent. So once you're done, you get an index. Here you can also index some additional features like word count, position, their font, any extra information that you're interested in. Okay. So with that, you can search. So if I want to search computer science, with this forward index, I'm not able to search it because I don't want to go through all the documents and search for computer science. So here is the inverted index. So once you have the forward index, you build an inverted index. Basically, the index, the key is the word. The value is the document. So for design, this word design, I have document number 3, 4, and 6 that contain the word design. So this way, when I get a search term, say design, I can go to my index and find out these documents contain this word. So that's basically the very basic idea. In actual implementation, it's a lot more than that, but I just want to give you a basic idea. And here, you can search one word. You can search for multiple words. So if you want to have search for engine design, how do you search for that? You parse out the search term. You search for engine and you search for design. You pick the set that overlap. So in this case, document number 6 contains engine design. So you basically can pick out the document. Once you have these 2 indexes built, here are some of the processes that I guess the process how you just explain how you actually get the search result. You parse the query first. There are a lot of science and a lot of work in just parse the query, because how do you take out the stop words like you don't need to search for these. And how do you take out like shoes? How do you make that shoe? When someone search for shoe or shoes, you have to know that means pretty much the same thing. So also then for each word you find out the document, you record the document size for each word, and pick the one that overlap. Or if you never find any document that contains all the words that you're searching for, you basically pick the one that contains as many as possible. So, and then you rank them. You might get thousands of results. You rank them and return the top number of results. So that's the basic idea of the full text search. So that's the search that you get for any document search within a computer. You can search your own document. You can search your file system. Pretty much any search, the principle is the same. But for web search, what do you need to do? You basically you have to collect the document, right? How do you collect the document? Basically, we're always joking. We're downloading the internet. Basically, it's hard to imagine, but that's what we do. And then you index the downloaded document. Of course, you have to parse out a lot of noise within this document, like advertisement or menu bar, navigation stuff. So anyway, you use the same principle, build the index, the forward index, the backward, the inverted index. And here is the index, the internet. You have a crawler, basically crawl the internet. You just follow the link, download the document, follow the link, grab even more document. You basically crawl. You actually crawl the internet. As you get more pages downloaded, you discover more new links, and eventually you will cover a large piece of the internet. So you download the document, and then you have these documents, you process them, you clean them up, you run through the indexer, basically build your inverted index, and then you put the index somewhere. Your serving system the searcher is basically the query front end that will serve the query. When you have a query coming in, your server the query front end is ready to serve that query. So from here all the way to indexer is basically backend processing. It's not real time. You crawl the web offline. You build the indexer offline. And at runtime, when someone actually search, that last piece is actually the real-time runtime engine that provides a search, the ranking, present the results. That's how you get the result. So, a lot of backend processing. Actually, the serving the query is fairly fast and fairly. I wouldn't say straightforward, but it's in real time, very fast. So these are some of the technologies that you can use. You can actually build your own search engine on the PC. These are some open source components that you can look. Crawler, you have a lot of open source crawlers, and also there are crawlers that for your personal use that will mirror a website, but these ones don't. They're not scalable. Plus, they don't have a whole interface. So Heritrix, Notch, they are very well documented crawlers. Search engine you've seen, Solar. If you search on the internet, if you use the search engine to search for search engines, you will get these results. And also indexers, basically, they're part of search engine. You cannot do any search without a search engine, without an indexer. So what are some of the scales that we're dealing with? For a regular PC or slightly high-end PC, you can handle millions of documents. You can download, you can process them, clean it up, and run an index on it, and you can actually serve. For example, you can, we're in wine country, you can download all the wine websites that you can find, collect them, and build a wine search engine. Vineyard, grapes, wine, different kind of wine. You can, I don't know how many wine sites are out there, but you can pretty much with a PC, you can do a lot of that. But you can only cover a small part of the internet. So you have one search engine, and now you want to scale it, to cover more, to cover the entire internet. So here's some of the statistics that's end of last year, or anyway, beginning of May. There are basically 500 million domains on the internet, and that search engine called Cool. Actually, they claim they index 124 billion documents. That's a lot of documents. And if you go there, they provide a kind of cool interface for you to search. And this is the search number of searches. I think that's December. Yeah. So here's the breakdown of the search engine. How many searches, how many queries over the entire internet. Actually, the user community use all these search engines. You can see Google has a dominant position. Yahoo is second. But look at these numbers. They are. This is over a period of 1 month. So you have 5 billion some searches on Google and 1.5 billion on Yahoo. Anyway, every single day you have millions and millions of queries, requests go through the search engine. So it's a very busy, very large system. So I'm going to talk about you have a search engine on your PC. How do you scale it to do the internet? Basically, the issues are how do you download them? You have the internet that's so big. How do you get all this information? And once you get them, even if you can download them, where do you store them? You have a disk of 100 gig, 200 gig, or terabyte, but the internet is much bigger than that. So how do you store it? How do you index them when you get them? You find a storage, how do you run the index? You need to, at the beginning, you need to build a forward index, you need to build an inverted index. So that's a challenge in itself. So once you have all this built, the backend work is done, now you're ready to serve. And you have millions of hits per day. How do you handle the traffic? Where do you how do you make sure, if you do any search, go to any search engine, average is probably 0.25, maybe less, response time. So you type in a query, a quarter of a second you get the results back. So that's quite amazing. You imagine, you do that for millions of people. That is something that's very challenging. So here is basically a conceptual model. Basically, you horizontally scale everything. So you scale your front end, you scale your indexer, you scale your indexer and index server and backend crawler. You scale everything horizontally. that's the concept. It's very easy to understand, but when you implement it, okay. So how do you partition this? How do you replicate it, make each machine work on part of it and provide results in the end? So here, you can have multiple machines working on something, but how do they talk, or how do they provide results that's what you're searching for? All at the same time, you have this ad server, like put the advertisement on the side, and also check the spell, provide you with feedback as you type. Maybe you mean this, maybe the word is spelled wrong. So the crawler, that's the bottom part. That's the crawler, we call it crawler. That's the part that actually collects documents from the internet. These are some of the issues we're facing. How do you keep your document set fresh? Politeness. If we're going to scale this crawler with hundreds of machines, maybe even more, and we go to a site, we download it as fast as we can, that basically counts as a denial of service attack. That server either crash or it will not be able to serve its regular user anymore. Right? So the politeness is an issue. Completeness. How do you get the information as much as you can? So when you provide the search query result, it's more complete. Respect the robot.txt. That's something that all the if you deal with a website, that's something that the admin administrator will put out and tells you, well, I don't want this part of the site to be crawled, to be indexed, because that part is either dynamic data or is not interest to a search result. But they don't want you to crawl, just reserve their resource. So, like I said, you can scale the crawler. You can download more documents using more crawlers. So there are a few options. You can divide each crawler to download a specific domain. But as you crawl, you will get pages that points to other domains. How do you handle them? You have to basically forward the domains that doesn't belong to you to another one. And another problem is if this machine handles this domain, this machine crash, that domain is gone. You will never get any document out of that domain, which may contain very valuable information. So this is one option. Another option is you basically randomly assign URLs. You don't care about where they're from. You get a URL, randomly assigned to your hundreds of crawlers to crawl. So each one of them will get a subset on average. You can assign them by using their hash number, a hash value, or any way you want, randomly assigned. But once you do that, you will face another problem, the politeness. How do you enforce global politeness? Basically, you have hundreds of machines that's going to crawl randomly. How do you make sure they don't go to one single site one after another, or at the same time? You still have a 10-second politeness to basically delay your download. So these are the issues. Well, this one seems a little bit better than the other one in terms of getting the results. If one machine crashes, some of the domains, some document within some domains will be lost. You will not get the document. But overall, you have hundreds of other machines that also goes to the same domain and download the document. So the fault tolerance is better in this. Anyway, I won't discuss the details, just to give you some idea, because in order to do that, either one option is very complicated. Anyway,
Which way do you do it?
I will pick the second one.
Is that what Yahoo does?
I will not expose any Yahoo specific information, but you can guess. You can think about it. Either way, there is no better way or the best way, or you have to deal with the issue.
How would you solve the politeness issue in option 2?
In option 2, you can have global like token kind of mechanism. You can have a token pass around, so they don't go to the same site at the same time, unless you hold on to a token. Right. Okay. So for storage, now you can download these, you can reach all these. So how do you store them? They're traditional NFS. I'm sure any computer science people will know. But it has performance issue or redundancy, whatever. Scalability is not that great. So Google came up with a file system that's distributed using basically just regular PC. They built a distributed file system. And Hadoop is another one that's built, sponsored by Yahoo. Yahoo is a very big contributor to this project, open source. You can look it up on the internet. And on top of, once you have a file system, you can store the files, but how do you organize them? When you extract features from this document, where do you store them? How do you make it easier to search? For example, when you process the document, you will identify a lot of features about the document, like the language the document is written in, the title, some of the keywords, most frequent keywords within the document. A lot of these features that you can, how many links this document has, and also how many inlinks. When you get more document, you can build a relationship of this document. How many inlinks? That's a very important ranking parameter. Anyway, so you need some sort of database on top of the file system. And HBase, Bigtable, these are the databases that you can use on top of the distributed file system. So these are the interesting thing about this database. People will often ask, why don't you use Oracle? Why don't you use traditional database? The problem is, as big as Oracle database, they're not big enough for the internet. You can traditional database, Oracle, or any relational database, they provide very good row-based. You have many columns. You have record each row. And it's transactional. It guarantees that your data is consistent, your data is accurate. Data loss close to zero. All these traditional functions, but they're not big enough, unfortunately. You cannot handle the data of the internet. So Google came up with this big table, and a lot of other people came up with similar mechanism. Basically, it's column-based. Instead of having rows with fixed columns, they came up with this idea. Some of you probably know. It's good to store hundreds and thousands of columns, basically. I should say, for example, if you store a document that you extract a lot of features, like I just said, when you downloaded a title or many features, but each document has maybe 10 features, but the total feature set is hundreds of them for all these documents. So you only need 10 columns for each document, but the combination of them has, let's say, 500 features. If you use a role-based database, you have 500 columns, and only 10 of them are public. The rest, 490, are wasted. So they came up with the idea that's column-based. The column-based means the database in the database, if you have this feature, this column is there for this row. But if you don't have this feature, this column doesn't exist. You can dynamically grow the number of columns as well. So that's the big difference. And with that kind of database, it's very scalable. very dynamic. It doesn't use the very restricted schema. So that's that. Now I'm going to talk a little bit about the indexer. The indexer, the point, the way you build the indexer is basically you have forward indexer. You can index. You use word-based. When you distribute an indexer, distribute an index, for example, you can have each machine hold the index for a particular word. So you can see if you want to index 1 million words, you have 100 computers. You have 10,000 words on each machine. You index them. But if that machine goes down, and that machine contains the word shoes, you search for shoes, you don't get that anymore. You get 0 results. So it's the same thing. So you want to maybe distribute your index in a different way. Basically, randomly select the document, build a local index that contains all the words. So when you serve, you may lose some results, but you get results back. So to scale the serving part, that's the runtime serve the query. You can have more front-end computers with shared IP. That way you direct your automatically distribute your queries among many front-end servers. And you get your query back and rank them and provide the result. So now you have a scalable web search engine that you can download, you can store, you can serve results, and it scales to millions of documents. But unfortunately, when you do a query, it will give you back mostly garbage because of these. Okay. So the document that you download has a lot of duplicate because web, the reason it's called web is pointing to each other, right? So a lot of documents reference each other. So when you follow these things, you download them many, many times, and you see them again and again. So duplicates. You have spam. I'm going to talk a little bit more about this. Porn, it's a bad word, I know, but it's a very important issue when we deal with searching. Freshness, completeness, relevancy, and how do we present the result. So duplicate. How do you have billions and billions of documents. How do you detect? This document is a duplicate of another. And which one do you remove, even if you detect it? Okay. And most of the time, even if you remove the document, the anchor text of these duplicate documents are different. See, I have a document I mark as search engine design. The other link that points to the same document will say basic engine design. Or the anchor text is actually contains a lot of information that's very important to search ranking. So we want to preserve that. So things like that, we need, when we do GDO, we want to deal with those issues. Spam, you have, if you go to some sites, all they have is links. They want to boost the ranking of a particular site that they're interested in. So they create those other sites that has many links pointing to the target site. Try to boost their ranking. Also, you go to other pages, they basically have piles and piles of keywords. There's no information, real information. Just to, when you do search, you will find a page and then they will show either ad or whatever that they want to show. So a lot of spam on the internet. We want to filter that out.
Do you just filter or do you blacklist?
Both. Yes. That's a good question. Many times they change so fast. So we want to just blacklist it. So anyway, this is actually a very important issue, even more important than duplicates or spam. There are regulations, there are whatever that we need to deal with it. Surfing, child, whatever, safety, and customer satisfaction is this is a big impact on customer satisfaction. So the technology we use same thing like you asked. We blacklist a lot of them, and we also use machine learning to deal with how do you classify, how do you know a site or page or document is the content is bad. Right? You cannot go through them all. Even if you want to blacklist them all, you cannot. You don't have the power, manpower. So you want to generate filters. So supervised machine learning is a very good tool. It's complicated, but it has to be done. Freshness. So while you search using general search engine, you get news that you will see okay, posted a few minutes ago or an hour ago. How do you get the freshness into the system? Of course, your crawler will have to know. And also, most of these news will feed their news into the search engine. That's once you get the feed are mostly structured information, so it's easier and faster to index them. So you don't need to crawl, because crawl is slow.
Are you talking about RSS feeds or something else?
Well, RSS feed is one feed, but most of the time, like Yahoo or Google, we have business relationships with CNN or these news producers that they give us feed directly.
So they have like a push.
Right. Yeah. But as I said, to build the index is a huge task. So you build forward, inverted. So you can do tiers. So you have your big indexers, you have smaller ones, maybe a few tiers to make your content. If you want to have a fresher content served for the query result, you can have multiple tiers, each one with different cycles. So you have every half hour you can build a new index. But when you do query, in order to combine the fresh content with the regular content, you blend them in. Okay. So that's how you achieve freshness and completeness. So relevancy is a relevance term. When you search for Paris Hilton, what do you want to get? Or when you search for Hilton Paris, you want a hotel or you want this person? So it's how do you rank them, right? So there's intent analysis. A lot of these science researchers do that. And when you search for the car manual, or what do you want? You want repair manual, or you want a user manual, or you want either flyers to get just to look at the features of the car, right? So that's all very important to analyze what user wants. So these are after that you need to present the result, right? You've got hundreds of query results coming up. Then how do you categorize them, and how do you blend the results? From different sources. You have news. You search for Paris Hilton. You will get news. You get her picture. You get videos, everything. But these come from different sources, and you need to blend them in and to provide a nice, readable format. So search monkey is another technology that Yahoo developed that actually do a better job presenting these information. Search tip is, as you type your query, it will have a drop-down menu that provides you with some hints. So now you have very good search engine that serves US pretty good, very scalable, serves good results. Now you want to push out to the world. Now you want to go global, Asian market, Europe, everywhere. So here are some of the issues. When you go global, the language, the regional behavior, and the user intent will be different. Actually, there are some of the technologies that's involved for you to go global. So here is a language, a sentence in Chinese. Well, that's the only other language I know. So it translated into English as investors are worried about the economic recession. Okay. So if you look at this Chinese sentence, how do you break it into words? There's no space between them. If you break this, that makes sense. Okay, this means investors. But if you pick a word with these two, that doesn't make any sense. It's not a real word. So this kind of language, how do you break them up? How do you pick out the words? That's a lot of linguistics, a lot of science goes into there. So just break it up, pick out the words. You know, you think, oh, it's no big deal. You know, just pick out the words, build the index. But to pick out the words is a very challenging thing to do. So a lot of linguistic experts, a lot of dictionaries, a lot of pre-built dictionary, large dictionary for you to match. But even if you have this, when you have a sentence, you have millions of words or phrases. How do you match them so fast? Right? How do you do that? That's something that our researchers are constantly working on. Basically, you need to make it really fast, because once someone types in a search query, you need to break it up right away. There's no vacuum. And spelling. How do you check the spelling of these? How do you know they give you a word that makes sense? You know, they don't give you these two. That doesn't make any sense. They will give you this or this. It's a combination. It's not like English words that you can look up a dictionary. And here's some regional behavior. In U.S., you search for football, you want to get NFL. You go to Europe, you search for football, you get something else, right? You don't want to, in U.S., you search for football, you get those European football. So, and local search, weather, traffic, all that, you want local information. You don't want to. It's very easy for us to identify where the search is coming from. So, based on your IP, based on your internet service provider, domain name, whatever. We have ways to figure out where you're coming from, so we can serve results that's more relevant to your local area. And the user intent analysis is something that's very interesting. I just put up two examples. In Japan, if you search, give a name somewhere, where the Japanese search a lot about a name of a place, an intersection of a street. Or one of my colleagues told me that's because their streets are not designed, or they're very old, ancient, street, cities and towns. It's very hard even for the natives to navigate their cities. So they put up a lot of search to search for the name of a street or a location. But if you, in US, if you type in the name, most of the searches here is product oriented. I want to search for a brand of shoes or cars, whatever. So these user intent are different. So we need to analyze that and provide more relevant results. That just said, a lot of people think, well, user intent, you don't know me, how do you analyze my intent? We don't need to know who you are. We just need to know where you're from, what you queried, what the last query that you did, or last several queries that you did. We can figure out a lot of things from this information. We don't need to know your name, your actual identity to do that. So here are some of the challenges that I want to put out, and maybe you can think about it. Content acquisition, storage, classification. The internet is growing very, very fast. So the estimate is for text document is not too bad. The cost of collecting and store them, just store them, okay, costs $1 million per year. You think about it, that's okay. 6 billion people in the world type text information every single minute of every day. They can only produce this much information. That is there is an upper limit. You cannot produce more than that. Right. So that's okay. We can handle that. But another challenge is most of the content actually on the internet are not searchable because they're private data or government, whatever. We can only search the information we can crawl or we can get feed, but a lot of the hidden information we cannot get to. So another challenge is, well, you don't always have text-based document. You have multimedia, voice, video. How do you search? Right now, we search based on metadata, based on the tags that people put on them, based on the description that people write about the picture, the video, or the link to this. But we're not able to look at a picture. We can tell, okay, this is a mountain, or this is a car. We're not able to search based on that. Research has been done. Researches has been done to do that, but to scale. Okay, if you want to scale to billions of images, and that's a real challenge right now. And the storage. I'm not sure how are you going to store videos, accumulated videos over hundreds of years. From now on, 100 years from now, we're going to produce so much video. We can handle the text because it costs $1 million to archive the entire text generated by a human being, but not video. These other searches are mobile related. Well, it's very good already, but it's still not as good, and a lot of people are working on it. The last one I put it up is openness and privacy. It's I think a lot of people know a lot about this and are concerned about this. Yahoo just announced that they're going to retain the data for 30 days instead of 90 days. Actually, it's not, Google, I'm not sure if it's 3 months or versus 9 months. Anyway, it's Yahoo is shortening the period that they retain data. Google used a lot more. I think it's either 90 days or 9 months. I think it's 9 months. It's not because Yahoo cannot handle it. It's because of privacy. The more data you keep, the better you can extract information, look at the trend, provide better results. But that causes privacy issues. Although, like I said, in order to analyze the user intent, we don't need to know the individual ID of a user. But if we want, we can. We can know. So how do you handle the government inquiry? Yahoo got into trouble providing this information to the Chinese government, and the U.S. government nailed Yahoo on this issue. So how do you handle, you work in a foreign country, you obey the foreign law, but the U.S. law prohibits you from doing something like that. So how do you do business in that environment? Another thing is monopoly. Monopoly, well, everybody loves Google, but unfortunately, without Yahoo, without MSN, Google would not be as good as it is today. Simply because they would not have the drive to improve it. So that's true for any of the products. So here is the frequently asked question that I got. If you ask me questions later, I'll be happy to answer. So first one, how do you search so quickly? Well, the answer is we don't. When we get a query, we don't go out the internet and look for it. Okay, we build the index already. We know what's out there, so we can search very quickly. The second, do you keep all the search results? When you hit a search, you can see, at the bottom it says, 5,000 results. You can keep going, next. How do you keep the next set of pages? We don't. We just search it again. Throw away the first 20, serve you the next 20. And that's it. We cannot keep the state, because keep the state for millions of users is very, very expensive, and it's not practical. It costs more work, and there's no need for it. It's cheaper to search again. Yeah. So how big is your computer? That's the question I got a lot as well. So it's not big. It's the same as, almost the same as what you have here. We just need many, many of them and do all the work at the same time. We're joking often that when you search anything on the search engine, the energy spent to provide you with that 20 result will be able to boil a pot of coffee for you. That's true, because if you look at how the index is distributed, it's distributed over many, many machines. When you send a search query, that query is directed to them all. They will all work at the same time, and they spend a lot of energy to give you that result. And that's it. Thanks.